All right, welcome to the next Nix Hour. So just briefly, the past weekend was NixCon. The website has all the information. It has the recordings. It has also a survey for the people who were there. And yeah, so I also had a talk there. I talked about RFC 140, which we looked at before in the Nix Hour. And yeah, you can find this here. It's this one, not all packages anymore. So if you want to watch me talk more, this would be a place to go. But yeah, also there were a lot of interesting talks, so check them out if you're interested. But yeah, today in the Nix Hour we have Mike here write a question down on the Nix Hour. Let's briefly go over that and then take a look at it. So I want to build CPython. I tried creating FHS, doesn't exactly work. There's some restrictions in the Nix shell or the Nix shell Nix build maybe. There are some scripts in nixpkgs to build it. How can I adapt this to a custom source? How to use that. So I guess the question here is, so nixpkgs has a lot of stuff that is useful. So CPython, let's look at that. So I believe that is the default Python version, right? If you do Python 3 in here, we get, well, it says Python 3, but I believe that should be CPython. Well, let's dig into this a bit more. So
it definitely is.
Okay, yeah. But yeah, so if you look at Python 3 equals in the all packages.nix, we get redirected a bunch of times. So Python 3.10 and Python 3.10 points to down here, Python 3.10. That comes from pythonInterpreters, which comes from here, the default.nix. And that then Python 3.10 comes from CPython, yes. And so I guess the idea is we want to use this building infrastructure to define maybe a custom CPython to have some patches on top. So or the latest CPython 3.13. Let's see, is it already in here? It is not in here. I guess that's the...
But it won't be here because it changes continuously because it's being developed.
So that's the unstable version, I guess, yeah. Okay, that sounds good then. So, well, I guess a kind of easy way is to just edit nixpkgs, and that would then also allow you to upstream it fairly easily. That would probably just be, these all import CPython splice packages. That should not be a concern. We have source version, we have hash. I wonder where these are configured. What?
You won't get a hash of the source.
Why do you mean we wouldn't get a hash?
Because everything that's built in Nix is built from a zip file. And the thing is, the latest version of CPython isn't presented externally except by Git. You have to either download it as a zip or you have to git clone.
So I believe, so we have source version in here, and the other versions use sources.python 3. Let's just briefly take a look. Sources equals... Yeah, so here the kind of versions are specified with hashes. And I believe underneath, if we look at this, CPython at the implementation, let's go into the, that's up here. If we look at the source version, what it does with that, so it gets, pythonInterpreters, that's not very interesting. Pass through, that's also not very interesting. Version, it gets that from that. Oh, but yeah, so it tries to get this, but right, I guess this doesn't have the latest version because it's an unstable one. So we can't fetch it directly from here.
No, you have to download the source. So we have to use
I see.
source equals something.
Yeah, yeah. Okay, I believe if we wanted to upstream this in Nix packages, we'd have to change this and be something like, well, it might look like something like this. I won't try this out like this. I think there's, but yeah, it would look something like this. I guess you'd add some notion of unstable to the source version, where if source version has a URL, maybe, then you fetch it from the URL directly. So you say source version .url, else you do this kind of thing as before. And we could also do source version .url or this here. That would also work, but these if-else statements are sometimes a bit clear, so I'll do it for now like this. And then if we go back to here, where is it? Here. We could then do this, copy it, say this is, well, maybe not 3. I'd say the convention is probably something like unstable, or 3 unstable. Then we call CPython. We call here. We also need to change this. This is related to cross compilation. Then major, minor, patch. I guess here we would say 1.3. Well, 1.3 unstable. I'm not sure. That might break some things. So let's use 3.13 patch release. Oh, this is a release candidate. Oh, this is currently there's release candidates for 3.12. While 3.13 is being developed. I see. So I guess unstable.
Sense to use overrideAttrs and override source as a whole.
Yeah, let's do that afterwards. If we assume that we cannot modify Nix packages itself. But yeah, that's a good point. So I'm gonna change the hash. I'm gonna just empty that. That should also work. And right, and then we need to pass the URL here. This is, I'm not sure if, let's see. No, I think that would be a decent approach to packaging this, actually. Yeah. So URL, let's quickly search this. How do you CPython 3. Or just CPython, I guess. Well, here, and so I guess it's the, is this the right repository? So just the master commit from here, perhaps?
Yes, that's right.
Do they have, I guess they don't have like any, yeah, no, they don't have tags for that.
No, your releases, you just have to go to the code button.
Yeah, or, oh yeah, right, we can do it like this. So right, we cannot really clone it directly in Nix, or, well, we'd have to use something like, fetchgit or so. But on GitHub, you can also download the tarball of the files directly. And there's like a URL for this. Well, actually, this will not work directly, but let's do it for now. GitHub.com, then the project name. So this is Python CPython. Then we say tarball, and then the commit hash. This gives us a download of that specific commit, and a tarball of that, so like tar.gz ending, I believe. You can also use archive, that's kind of another way, but then you need to say .tar.gz. Same thing though. All right, but if we download that, let's go into CPython, and let me actually open this in a separate one here. CPython default.nix. Okay, if we look at it here, source version. Right, we are using fetchurl. And so fetchurl here, oh, actually this also has a tarball in it. That surprises me a bit, but we shouldn't do this for GitHub actually. So I believe these tarballs here are deterministic, so they never update them ever, so they always evaluate to the same hash. But on GitHub that's not the same. So GitHub regularly sometimes changes the tarballs so they don't have the same hash. And so what we would generally do in Nix for that is to use fetchzip instead, or you can also use fetch from GitHub. That's a wrapper around that, around fetchzip. That then unpacks the source and hashes that instead. And that is deterministic even on GitHub. But so here, if we just use fetchzip, that would break compatibility, or that would break these kind of URLs. And I also wonder where this gets unpacked actually. I believe this is just the standard make derivation unpacking that's going on. We have pre-patch. No, there's no special unpack here, it looks like. All right, so then let's just do this. Let's say if we have the source version .url, well, it's a bit, you might get requested for some changes when you, if you put that in a pull request. But we could do this. Then here we say URL equals source version.url. We say hash equals, well, inherit hash. All right, else we do the thing from before with a fetch URL and the old one there. Okay, let's make this a bit nicer, and let's also do this. Okay, yeah, the Nix formatting is a work in progress. All right, so source, we have fetchzip or fetch URL. So
I think
the
you
hash.
need to put line 166.
Oh yes, thank you. All right, then in here we can say Python 3 unstable. We have this, we have that. Okay, now we just need to be able to build it. Well, I guess we can use pythonInterpreters directly. Let me open another window here. So, right, we can't just do this unstable because it's not available. We saw this briefly earlier, but by default it's under pythonInterpreters.python, and now we have the unstable one here. Unstable. Let's try building this, and we get the problem. Oh, no such file or directory. Oh, okay. So apparently there is patches specific to those. Well, that complicates things a little bit. But yeah, so if we go in here, we can see that there's these directories, and I guess these all have certain patches. Yeah, like the no ld-config.patch is one that applies to all of them, and I guess they all need their specific one because there's no common one that works for all of them. So if we want to upstream this, we would have to do this, create this directory. I'm just going to copy the previous patch and hope that it applies, which might not be the case. 3.13. All right, let's try building this now. And we get, oh, undefined variable fetchzip. So in here, in the default.next, we have all of these arguments. We have somewhere in here fetch URL. At the very top. I would probably refactor this a bit, but fetch zip. I also noticed there's a fetch git here. I want to briefly look at what this uses. Oh, okay, this fetches a patch. That's fine. All right, let's try this again. And we get Nix to finally build it. And it should spit out the right hash after downloading. All right, fetches it from GitHub. It should now unpack it. And we get, oh, do not know how to unpack source archive. Oh, I guess it doesn't have the tar.gz ending actually. Okay, maybe we should use the archive URL instead of the tarball one. This was up here. So yeah, let's try the archive one. I guess that I'm not exactly sure where the problem comes from here actually. If we do this, we fetch the .tar.gz. And okay, we get a hash now. So let's copy this, put it in here. And then let's just see how far we get. Oh, we can see here, patching file, yeah, applying patch ldconfig, and apparently it applied successfully. So that's good. And we are compiling. Well, not yet. But this might be, I'm hoping it succeeds, but let's let this run in the background. So let's briefly review the changes we made here. We added fetchzip, we changed the source handling here. Oh. And we added this one. And I guess if we want to actually upstream this, I guess we should also in the, well, let's go here. In the all packages.nix, which I already opened up here, pythonInterpreters. Oh, the syntax highlighting apparently doesn't want to work anymore. But we would also add this here, Python 3 unstable, like this. And now I wonder, I guess all of these attributes exist as package sets too. I feel like since it's unstable, it might not entirely be necessary. So yeah, I'd probably keep it at this. Just have this be Python 3 unstable, and that should then also allow you to build it. Yeah, but this takes a lot of cores in the background, and I'm not sure if I can actually build this in this time. But I guess let's see Hydra and figure out how long these Python builds take. So I'm going to go to the hydra.nixos.org, go to the nixpkgs project. All right, then I'm going to go to the one at the very bottom here, the trunk one. This is builds from the master branch. Okay, we have all of these. And now I guess jobs would be the best way. Oh, this didn't take as long as I expected. So let's do Python 3 E12. Let's see. All right, Python 3.12. We have, oh, nice. We have all the separate architectures. I'm on this one, so let's try seeing this. Okay, we have all the builds over time for this attribute. Now let's go to the latest one, and we see, oh, it only takes 8 minutes. 8 minutes. That seems doable, though I wonder how much parallelism this used. Can we see this here? I'm not entirely sure. Maybe in the logs, actually. Oh, this changed. Interesting. Let's see, do we have like a J-J in here? J2. Build flags, J2. Okay, that's okay. 8 minutes with only 2 cores. That's actually pretty good. And this is indeed Python. Yeah, okay, let's try building this then actually. We might be done before the end. So I'm gonna do, let's build this attribute. And I also want to set a J to, so this dash J gets propagated to the underlying make. We can also use cores, I believe. And I'm just gonna use 4, I think. It should be good. And we should hopefully see the dash J in here as well at some point before it starts building. Yeah, okay, let's leave this running in the background. And meanwhile, I think we can take a look at how we would do this without changing Nix packages. Yeah. Okay, I'm gonna go to actually a separate window here. So these are the changes we want. Let's try to write an overlay that implements these. I'm not sure if I can manage that, but should be. Well, we can. No, that should be. Well, it might be pretty tricky actually, but let's try. Before I do this, though, we might want to have a separate Git work tree to work on this actually, to not override these changes here. Actually, I guess no. Let's have a separate work tree. I'm gonna add one. Let's see, ..nixpkgs 2, or let's do CPython, and I want to copy the head commit, or check it out at the head commit. So Git work trees is a kind of nice way to have a separate directory to work on things without having to check out the same directory here. So nixpkgs CPython Python. Oh, what Git work tree? Nixpkgs CPython. Well, did something happen here?
Directory.
Yeah, I should be in the parent directory. Right. Oh, okay. Well, seems to have worked. Okay, let's. Well, I guess we actually don't even need a nixpkgs, but yeah, we shouldn't actually need a nixpkgs. We're trying to override it, not change it. So actually, never mind. But we showed Git work trees. That's useful. So I guess let's go into the Nix Hour here and create a directory for 32. I'm going to add an overlay.nix file. I'll start off with the basic final pref. And I also want a way to test this. So I'm going to Nix Hour 43. And I want to have a command to test this. So I'm going to do nix build. We can say nix build, nixpkgs, and actually I hope I think my next path should be fixed now. Oh, no, it's still pointing. Ignore this. So I think let's have this, or let's be adventurous. Let's have a flake.nix, and I'm gonna use outputs. We also gonna be adventurous. We're gonna use the flake registry here. And we're going to say packages dot that's x86 for Linux, and then Python. Let's say Python. Yeah, also Python 3 unstable. And then we're going to say let packages equals import nixpkgs with overlays set and system set. The overlays should be our one file in here. So we need to import this overlay.nix. I think. Yeah, okay. And then we can say packages, so we're gonna overlay this onto Python 3 unstable as well. Okay, now let's try building this and discover that it doesn't work if we don't do anything. All right, we need to add the files so flakes can find them.
Maybe use path.
Come again?
Maybe use path instead of git to not copy the whole directory into the repo.
Oh,
into the store.
Path. Oh, you mean like import nixpkgs.path?
No, I mean path : dot hash Python 3 unstable.
Path : oh, I mean, I see. So, well, path : dot like this.
Yeah.
Yeah, although I guess, I mean, we're not in nixpkgs here. There's only these couple of files here. So I think
but it
that
still copies the whole Git repo.
Oh, the entire Nix Hour Git repository. Oh, I
Yeah.
see. Okay, so this would be preferred then. Nice, thanks. Right, and then we don't have the attribute, so, but let's see. We should be able to add it here. Let's just have a, let's set it to hello, just to make sure it works. Yep. Let's also say print out path, print out paths. Okay, so we can see build hello for now. But yeah, okay, now the kind of hard part. Let's try this. So I guess we could try copying essentially the same thing from nixpkgs and use, well, where was that? pythonInterpreters. Python modules development. I think it's in development interpreters Python and then in here. Yeah. So we could copy pretty much this here. Let's try this. So Python 3 unstable is a callPackage, and now it's going to be a bit tricky because we need to make sure we have everything in scope and it is the right thing what we expect, and then we also need to make sure that this CPython here somehow supports the source version. But let's worry about that later. About the callPackage here, let's see where this callPackage comes from. There is a packages.callPackage, but this could be different. Let's go up here. callPackage comes from here. And this is, so we need to go into allpackages.nix and figure out what this actually is. pythonInterpreters equals this here. So it's just a normal callPackage. So callPackage calls this file, and then the kind of callPackage is the same one that's available up top here. And this is the standard one. So we can just use final.callPackage. And we also have self is spliced packages. This should also be final.spliced packages. Okay, Python 3 unstable, and that should also, oh yeah, actually that's something good to mention here. The spliced packages in here. Spliced packages, so then here we used spliced packages.python 3 unstable, but these spliced packages mirror the top level attribute set. So to actually have this work, we need to have the attribute in the top level. So this here, Python 3 unstable.
Like I just interrupt you. What's a splice package?
Yeah, good question. So that's for cross compilation specifically. And I recently also kind of discovered this. It's not very clear at all. But basically, if we do, so let's say we do a cross compilation with packages cross, and let's say AR64. And so in here we have the entire package set. So right, like hello, and that's then cross compiled. Yeah, but I'm not going to do that for now. But we also have this spliced packages in here, and that's also the same package set. But in addition, all of the packages have a spliced attribute under them. And this then has these kind of attributes, which are then a different hello for specific pairs of how you cross compile. I don't know the details about these, but that's what the spliced packages gives you. It gives you this spliced attribute. Whereas the default one, so here hello.spliced, doesn't have that. Spliced not found. And so the reason this exists is because callPackage uses the spliced packages for passing arguments. So if we go in here, top level, I believe it's splice, go to the bottom here, we see here's the definition of callPackage that uses new scope, and new scope uses spliced packages with xorg, and if we go to the definition of that, it uses spliced packages, and if we go to the definition of that, well, it's well, it's a definition, but also we have spliced packages down here, which is also spliced packages, and that's well, kind of pretty much the same thing. And so yeah, that's what callPackage uses for arguments. And so in here, like, let's pick any package. I mean, let's go to hello. Hello should actually now be in here, yeah. So if we go to hello, all of these arguments up here are called with callPackage. So in cross compilation, these will have a hello.spliced attribute. And so then, I mean, we can also maybe print this, and we can say built-ins.trace does hello have spliced, and then in here we say lib.bool to string hello question mark underscore underscore spliced. Okay, and so we just trace this, and now if we do a, let's keep this up here, if we do a nix build or nix instantiate just dash a hello. Oh, we get Stack Overflow. Is this because we tried this? Oh, I guess it's kind of recursive actually. So let's not have the trace up here. Let's have it in like here. That might work. Yeah. So let's have the hello name back here. Okay. Does it have splicing? And here we get the answer false. Okay, but that's because we aren't cross-compiling. If we do packages cross AR64 hello, we can see, does hello have spliced? Yes, it does. So that then applies there. And then if we want to get into more details here, where is this actually used in the end? Actually, this is a bad example because hello doesn't have any dependencies. If we use another package, let's say, I mean, anything really works, but something with native build inputs. Yeah, sure, maybe this one. Yeah, so in here, so all of these attributes now have the spliced attribute during cross compilation. And now you pass them to build inputs and native build inputs. And this is where we really need to distinguish between packages for the build platform and the target platform, host platform. Well, you need to distinguish it here. And so this is where the spliced attribute is then used. So if we go into standard env generic make derivation and look at underscore underscore spliced, we can see here that we have for, let's go to build inputs and native build inputs. So build inputs uses the spliced attribute and the host target of those attributes, while the native one uses build host. Yeah, and we can also see here the fallback or DRV if there is no cross compilation happening, which is the default. So yeah, that's a kind of 5-minute, 10-minute explanation of how cross compilation works. It's not perfect though, there are some problems, but yeah, that's what spliced packages is. And so in here, right, spliced packages, we have, right, we have, so final, as we saw before, we have the entire package set here, and then we have spliced packages, which contains the packages with extra spliced arguments. And honestly, this is kind of just a hack. I'm not, I think we talked about this before in a previous Nix Hour. I'm still not sure why Python uses the self here with the spliced packages, but supposedly it helps with cross compilation. But yeah, so in here we also, this would also work. But well, actually in this case it wouldn't work because we aren't using Python interpreters here. So actually this is good here. Okay, let's go a bit further. What else do we need here? We have inherit Darwin. Darwin, that's just an attribute from final containing Darwin packages. Although I'm not on Darwin, so this shouldn't really matter for now. And we have pass through fun. Let's see what this is. Packages development interpreters Python in the default.nix. And we have pass through fun. Well, we could just copy this, I suppose. Yeah, this is a bit messy actually. Well, let's just copy this. See if it works. So we're gonna import this, but now of course we are not in the same path. How we can do this is, and we will also need this for the CPython up here. We can do final.path. That is an attribute pointing to the path of Nix packages. And then we can append the subpath that we need access to. So in this case, that is this one here, packages development interpreters Python, and then the pass through fun.nix. So let me copy that. Pass through fun.nix. And instead of importing it with args, that shouldn't really be necessary. We could also do a callPackage, I believe, though that might do some other weird things. Let's try it for now. And well, I also want to quickly look at what the pass-through fun really does. So it just takes the arguments up here, and then it returns a function. That should be fine. Yeah, that should be fine. Okay, do we need anything else? Right, we need the same thing here. So let's also copy this here. Instead of pass through fun, it should be CPython. All right, and all right, then we also need the source version thing. So that will be a bit trickier. Let's see, we might have to use some .override for this. And we could have actually maybe also used override for the entire thing here. But let's just explore some different ways of doing the thing. So pass through fun, we need CPython, and we need to influence how the source gets used from it. So let's go into here, CPython. That's a default.nix. Okay. So in here, this is where the source gets set. We cannot really influence this directly, or maybe we can. Let's see if there's some way to override these attributes. So this is a big attribute set over here. Let's go to the, actually it's not an attribute set, it's a let-in. So that, okay, so source, where is it used? Source, it's used in make derivation. Is that at the end? Oh, there's a lot of things here, but yeah, that is at the end. But I can see here, we have a closing attribute set here, and this is the beginning. So it doesn't look like we can override this attribute in any way. So the only way I can see to make that work is, well, there's always kind of many ways to do the same thing. We could also override stdinf and change how make derivation, like the source directly. But that's a bit hacky. So instead, I think let's use a .overrideAttrs. And so here's source version. So we don't pass the URL here. Instead, we're going to use, well, let's say this is the kind of unpatched, or let's say original. Okay, let's make the annotation work. And then we're going to say original.overrideAttrs. Now here we can say, let's say final attrs. Actually, this is not the final attrs. This is the prev attrs. The previous ones. And so here we can then override source to something else. And so here we want to say final dot, we want the fetch zip. We can also use fetch from GitHub actually. Let's, for some change, let's use fetch from GitHub. Now we can say owner, we can say that's Python, the repo is CPython, the revision, we can also copy this from here. And then the hash. And this should be the same as the one we got previously, but let's just have Nix refetch it. Okay, we have the source set and...
You have to close bracket on the line 25.
Oh yes, thanks. Okay, and then let's try it out. Let me close some stuff here. Go to Nix Hour and let's do the Nix build. All right, and we get an error. What is the error? Well, no such file or directory. Oh, we still get the same error as the that we need some some patches, right? Okay, to fix that, that's going to be a bit more tricky because in here, if you go in here and see CPython, it's going to get patches from where? Well, CPython default. So it gets this LD patch from somewhere. We'll see patches here. Right, so it fetches this if the version is that. There's some optional version things. It fetches this here, no LD config patch, and that is, oh, it has there's an argument here to override this. So no LD config patch. Gets it from here. So how can we override these arguments? This is, I believe this is the CPython file. So I think we can just pass an extra argument here and say, what was the argument name? Well, this was the default. And by default, it would have used the CPython one. And actually we can just, we know that the other patch succeeded for the other version number. So we can actually just copy that. So let's do this. Again, path name here. Oh, or alternatively, we could also kind of imitate that we are version 12. That's a bit hacky. So let's do this. Final.path. We take CPython, and now we need the major version, minor version. We can duplicate it here, or maybe a better way would be to say move this up here, source version, and then we can use it here. Yeah, and we need to inherit source version. So here inherit source version. Okay, we have.
We'll use 312, right?
It will use 3. Well, we pass source version here still. Oh yeah.
But we need to use 312 for patch. So
oh right, yeah. That's a good point. Yeah. So in here 312. Well, then we might as well hardcode the 3 actually. That looks a bit better then. So let's not do this. Let's just move this back. Okay. Let's also do a quick refactoring. CPython root or base. Let's have this in here, or I guess it's Python CPython. We only use, well, we use Python as well. So let's have this in here, and then just say CPython, or actually this Python base. Okay, and then here as well, Python base plus this, and finally in here, Python base plus this, and then let's do this, and we don't need this. Okay, I think this looks pretty decent. Let's try it out again. Well, I mean, it looks hacky to be honest, but let's try it out anyways. Let's go in here, Nix build, and it's building stuff. That looks pretty good. Let's wait until it fetched the source, and then we could also compare it to the old hash. See, well, unstable. Yeah, that is the same hash, so that sounds pretty good. Wait, we do pass the hash here already. Where did I... That's confusing me a little bit.
You have a in SRC there.
Oh, down here, yeah. Actually, then this hash should be... Let's actually do a throw here, just to see whether it gets evaluated. And it looks like it doesn't, so we can just remove this. Well, removing could cause it to fail. Yeah. Function called without required argument hash. So yeah, we're just gonna say let's do like throw. This shouldn't be necessary. It will confuse people who when there's a bug in this, but yeah. So let's try it again. And we can see it is building stuff. Let me also pass here. I don't want it to take up all my cores. I'm not fully familiar with how to specify cores in here. Oh, it's also -- cores. That's good. Cores 4. All right. And actually, it might have built. Yeah, it built in the background. And I guess we did change the nixpkgs version. Actually, that would be interesting to see. Can we make it use the same cache that we already built here? To do this, let's try. So in here, what commit am I on? Let's use this ref powers head. So this is a commit we used, but we modified nixpkgs a bunch. Well, this here, but we should the same changes should have been done. So to do this, let's go into the flake and let's explicitly specify nixpkgs here. URL equals URL equals GitHub, then nixos nixpkgs, then the commit. I believe this should work, and then flake equals that should also work, right? Okay, nixpkgs, we import nixpkgs, we have the overlay, this should all be good. Let's try this again. So it's fetching it. Hopefully it won't have to build anything now. If it does build something, then we could maybe even debug why this happens. This is taking... Oh! It was able to reuse the same path. B1H, is this the same one? Oh, let's scroll up a bit. Yeah, it's the exact same path. So that's actually really nice. So that worked. We could also... So that's one way. And actually, let's extend this a bit further. Let's say we want... Because there's one difference that we have still here, and that is that pythonInterpreters isn't populated here. But we could also do this. We can say pythonInterpreters equals, and then we define our one. But we need to make sure that we don't override the old ones. So if we just try this, let's see, pythonInterpreters, okay. Now if we, let's see, this will probably fail because something depends on Python, on other Python versions. Yeah, now we get Python 3 minimal missing, so that's another attribute in the Python interpreters that wouldn't be present for now. And so overlays completely override these attributes, whichever attributes you set. And so if you want to preserve these, we need to somehow extend them or persist the old values. Now, one way to do this is to just say prev.pythonInterpreters. That might be the right solution here, actually. But sometimes it's not, and that really depends on how it is defined. So let's see how pythonInterpreters is defined here. So top level all packages, Python interpreters. So it does a callPackage. So callPackage adds some things on top, which we might influence with this actually. Yeah, this will actually influence the result a bit. But there's no really good way around this to be honest. So callPackage adds things like .override into the result, and .override will then reevaluate this file and this function with the changed arguments. So for example, if we were to say .override, that's tradeoffs, and then say, what kind of arguments does this take again? It takes like lib f, well, let's say stdinf, for example. Or actually Python packages extensions. That might be a significant one. But yeah, so we could say override, well, let's have this in here. We could say .override, and then Python packages extends, I believe, something like that, or extensions. We could say this, pythonInterpreters. Actually, we could simulate a failure here, I believe. So if we say pythonInterpreters equals, so we set it down here already. This could be done in separate overlay. Well, let's just simulate this here. Let's not actually evaluate it. Well, let's do it like this. Okay. Python interpreters dot override.
Package.
You mean in here?
Just name it Python interpreters.
Oh, yeah.
Broken.
Yeah, good idea. So we could say pref.pythonInterpreters.override. Actually, we could say final. We aren't overriding Python interpreters here, but a separate attribute, so we can use final. So .override, and we say, what was the argument? It was, I keep forgetting this. Default.nix Python packages extensions. Okay. So Python packages extensions equals, and I believe this is actually also a set of overlays, which is just adding to the confusion here, but let's roll with it for now. So yeah, we could, for example, say in here, let's have a throw in here and say, nope. Actually, Python overlay is evaluated. Okay. Now, if we try it with the others, so the standard ones. So let's go in here and try like a Nix build. Well, we don't have access to any others at the moment. Yeah, and in here we also need to, maybe let's finish this briefly and say Python 3 unstable equals final dot Python interpreters dot Python 3 unstable. We could also use inherit here, but that's fine. So we can say, let's modify our flake to expose the entire set. So right now we just have Python 3 unstable. Let's expose the entirety of packages somewhere. We could say this is, I guess, Python packages, let's say Python interpreters. Actually, this is a bit ugly. We should do it like this. Let this in here, and then we say inherit packages Python 3 unstable, and let's also say Python interpreters. Okay, now we should. Oh yeah, broken. Yeah. So we override that here. Now let's try this. Python interpreters broken dot, and now let's try normal one, like 3.11 or 12. And this should actually, let's try evaluating this, and we should get, well, okay. Evaluation is too strict here. Let's just try building. Oh, actually, that does work. That surprises me a little bit. Let's just make sure this is done correctly. Dot override. Yeah, I'm actually not sure why this works. We are almost out of time though. But yeah, so just kind of saying here, if we use pref.interpreters / so updating the attribute set, the result of overrides like these, so these overrides wouldn't be applied to this here. And I don't think there's a good way around for it in this case. But so yeah, not sure why this doesn't work. Well, why this doesn't throw like this. Okay, so yeah, this works. Let's also just verify final time that we can build Python 3 unstable. Yep, that works. And let's also... Oh yeah, next run. Let's see, does this work? Would it just run Python, I guess? Yeah, very nice. And we have Python 3.13.080. And let's do a 1+1. Well, barely a demonstration that it works, but it seems to work. So that's pretty good. Yeah, maybe final thing. We copied this here, but I believe we could also do something like, let's copy this here. Let's say unstable prime. We could probably also do something like Python 3.12. So in this final.pythonInterpreters.python 3.12.overrideAttrs. And that would involve looking a bit more into the source, but might be a bit cleaner. We would set arguments like null, like source, like well, somehow source version, but that would be kind of hard to make sure it works. We also have, I guess, pass through fun. That might work just fine. And actually, that doesn't work. It's not a derivation attribute. So this might also work. Let me just keep this in here as a might also work. Dot dot dot. Okay.
But you also need source version there. Oh, you can also override source version, right?
Oh, probably not with overrideAttrs. So this overrides derivation attributes. And source versions probably isn't a derivation attribute.
You can override a source version and then override others for the sources.
Something like this. I want to briefly write this down here that, well, I can do this afterwards, but I'm going to push everything to the Nix Hour repository so you can find the code afterwards. And yeah, we are out of time though. I